Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about interrupt process. So interrupt is some other important task we need to concentrate. So that is the interrupt. So once interrupt occurred, that interrupt service routine should be executed. After execution, it must come for a main programs. So first thing, the interrupt is, we can take an example. For example, if you have an interest, so interestly normal tasks are running, so that will be monitored with the microcontrollers. Whenever there is some abnormalities, for example, fire is detected with the fire sensor, so that signal will be given to the microcontroller. So microcontroller already busy with the actual schedule, it works for that. But once this interrupt is received, what happens? The microcontroller stops that execution and runs that interrupt service routine. For example, if the fire is detected, we need to turn on a siren for an alerting all the peoples. So the microcontroller stops the current execution, it runs the program of interrupt service routine, and that is the siren, making a siren. So after making a siren, it need to come back to the main program. So this is the actual interrupt process. So whenever we need, we can enable interrupt, we can disable interrupt also, this will be possible. So whenever there is an interrupt occurred and then interrupt is enabled, thus interrupt will be processed. So if it is a disabled, whatever happens, it will not be considered. So once if the interrupt is enabled and there is an interrupt detected, so this will be interrupt is enabled and then interrupt routine will be executed. So once the interrupt occurs, what happens? That current program counter value will be pushed in the stack. So because we need to return back to the main program, so we need to have that address. So that address is available in a program counter. So this program counter value will be stored to stack. So once this program counter value is stored, what happened? We need to execute the interrupt service routine. So what we do, we take an interrupt vector address. So each interrupt have an interrupt vector address. There we mention some addresses, that program only we are going to execute. So we go with an interrupt address table, we load that value to the program counter. So once the program counter is loaded with that value, that program starts executing. So after completing that interrupt service routine program, we have one instruction called RETA, that is return from an interrupt. Once this return interrupt RETA interrupt, that is return from interrupt instruction is detected, so what happens? The program counter will be reloaded from a stack. So already we have loaded the program counter with the values to the stack. We pop the values from a stack pointer and we restore to the program counter. What happens? The program counter starts continuing the program where it stopped. So interrupt priorities. For example, if there is a two interrupts occurs at the same time, even there is a small microsecond variation, it will be considered as a first, which interrupt is occurred first. But if the both interrupt occurred at the same time, what we need to do? So we know that which interrupt is given to the high priority, but microcontroller don't know. That's why we are taking a priorities. So here we have two groups. One is a high priority groups and another one is a low priority groups. So what are the interrupts are important? So that interrupts will be combined and given a high priorities. Remaining interrupts will be combined and given a low priorities. Again, if there is a two interrupt occurs at the same time with a high priority, what happens? So that cases we have a default interrupt priority orders. That priority orders will be given importance. So based on that, the interrupt will be selected and executed. So normally we use this default priority orders. If we want to change that, we use this higher priority group or lower priority group to depending upon that. So what are the interrupts available in high priority will be given a first preference, and that remaining will be given a low priority groups. Look at this SFRF interrupt request register. So this is an interrupt enabled register. So each interrupt we can use the interrupts. Look at this EA. This is an overall enabling the interrupts. So these two will not be used in this 8051. Higher version only used. This is a timer 2. This is available in 8052. This is not available in even 8052. Even it will be available in higher versions. Look at this. This is an external interrupt 0, external timer 0, external timer 1, external timer 1. That is serial port interrupts. So we can enable or disable it with this date. So this is an enable of overall this is enable of individual interrupts. For example, this bit is 1 and this bit is, this bit is 0, whatever these values, all the interrupt will be disabled. So once if this EA is 1, so next only it considers this corresponding bits. So if EA is 1, again if EX is 1, what happens? This external interrupt 0 is enabled. So again this EA is 1 and remaining all the bits are 1 means what happened? This is external interrupt 0, timer 0 and external interrupt 1, timer 1, serial port, timer 2, everything is enabled. So this EA is for overall enabling, these individual bits is for that corresponding interrupts. So if both will be 1 only, that interrupt will be enabled. So for example, I want to enable only timer 1 interrupt. What I do, I make EA1 as 1 and thus time ET1 as a 1. So it enables that. So remaining I can put a 0. So remaining all interrupts will be disabled. Thank you.